Hello friends, this is in continuation with the first video. Now in this video we'll try to solve second order ordinary differential equation using MATLAB and Simulink. In this session we'll be considering two different problems. So first problem is a simple damped oscillatory problem which is represented by this equation, that is d square x by dt square plus 5 dx by dt plus 9x is equal to 0, with initial conditions that at t equal to 0 x value is 2 and dx by dt is minus 2. Now in this the input function is 0, so we can rearrange our second order differential equation to get in terms of d square x by dt square, which is just a minus of 5 dx by dt and minus 9x. Now again the approach is same. What we'll try to do is we'll try to use this as an input in the integrator. We'll get this as the output, that is dx by dt, and then this dx by dt goes into the second integrator to get the x. So as shown in this figure, we have two integrators connected in series. The input to the first integrator will be d square x by dt. We'll get the output which is dx by dt over here. Then this output of the first goes into the input of the second, and we'll get the output of the second as simple x, which will be a function of t. Okay, so let's go down to the MATLAB window. Okay, so let's try to arrange the components in the model. New model, we'll click a new model. We have a new model over here. We'll use blocks. Okay, we need one integrator is there, the other integrator is there. Okay, what else we need? Let's look at this. We need a scope. Is there. We do not need this. What else we need? Summation sign is there. We need one gain. We do not need this thing. Oh, sorry. Now this is d square x by dt square. The output is dx by dt. Over here the output is simple x as defined over here. Now dx goes into the gain, it goes into this summation, and the gain is 5 as defined over here. We'll change the signs over here. You can change the sign of the summation sign, keeping both negative. This. Okay, now our model is complete. D square x by dt goes into this, we get dx by dt. This dx by dt gets multiplied by 5 and goes into this summation. Then this dx by dt goes into second integrator, we have the output x, goes multiply with, I guess, 9, sorry for that, 9 gets entered into this summation. So we over here this total summation is minus 9x minus 5x dx by 5 dx by dt. This is equal to dx square by dt square, which is equal to this thing. So our model is complete. Now we will give the initial conditions. In the first initial condition is 2. In the second integrator, the initial condition is, over here the initial condition is 2. In the first one we'll keep it minus 2, because this gets integrated to get dx by dt. So initially dx by dt is having minus 2, so minus 2 will be fed in the first one. The model is complete. Let's run this thing. Before that, let's save it with some name, ODE2. Let's run this thing. It's successfully run. So let's see the simulation plots. Okay, so it's there. So this is the simulation plot for this. Now let's check the solution by using MATLAB. For that, we'll have to write a code for this. Let's write name OD. Let's say name is OD1. Let's take it OD1 is equal to, okay, this thing, D2 x, which was equal to minus 5 star dx minus 9x star, noted commas. Let's run. Initials, x at 0 was 2 and dx at 0 was minus 2. This is done. Okay, so now we say x is the solve OD1 comma so this is our solution of x in terms of t. Let's clarify this thing pretty. So it is of this type. So now we give a time span. We vectorize our equation x. Done. Then we say plot t comma xx. So we have a plot which was similar to that of which we did in that case. Now let's check the solution. So as t approaches infinity, this entire terms e raised to minus 5t gets vanished up. Okay, this again gets vanished up because it's again e raised to minus t. So the at steady state, that is t approaches infinity, the entire solution gets 0, which we can clearly see over here. As t goes beyond 5, 6, 7, 8, 9 or greater than 4, all the value approaches 0. So this is the final solution of this particular ordinary differential equation, and this is how we try to solve second order differential equation using MATLAB codes, which I've done over here, as well as using Simulink. Clear? So let's take another problem. This time the problem is 3d square y by dt square minus dy by dt plus 6y equal to 6 sin t plus 2 cos t, with the initial condition that y at 0 is 1 and y dash at 0 is 2. Okay, so in order to first let's solve this equation in the MATLAB codes, and then we'll check with using Simulink. So let me clear this thing. Okay, so again let's write a code. Let's say OD1 something. It was 3 star d2 y, because it was second order in y, d y plus 6 star y equal to 6 star sin t plus 2 star cos t. Okay, this is done. Then we initialize the conditions at y at 0 is 1 and dy at 0 is 2. Done this. Okay, so again let's say OD, okay, let's say y is equal to d solve ODE1 comma initials. So it will try to solve using this initial conditions. So you can clearly see over here at the end it says busy, that means it's still calculating it. This is the solution. So we clear the things. So this is the final equation. This is how the final equation looks like. It's a quite big one. Okay, no problem. Then we'll give the time span, let's say from -5 to 0.01 with this much of size up to 5. Okay, then let's vectorize that. So y eval it's done. So plot t comma y. So this is how the result of this second order, which we have seen over here, look like. So the result is something like this. Okay, so now let's try to solve this thing using Simulink. So in Simulink we need to create a model. First let me clear this window. Okay, so for that again go to the Simulink library. We'll click this new model and we'll try to create. Now this is important because in this number of variables will be much higher than the previous ones. Okay, so let's first go to the common blocks. What are the common blocks we'll be using? So we'll be using gain, we'll be using we'll be using scope, we'll be using summation sign. What else? We'll obviously integrators, 2 integrators. We need a sine and a cos. So for that we'll go to the mathematical operations. So over here we have a trigonometry. Where is a trigonometry? If they're not there, we go to this thing, commonly resource. So if we're not able to find it, we can search it over here. Trigonometry. will search the trigonometry block. There is no trigonometry block over here in the problem. So let's find it out. Where is the trigonometry? Oh, over here. It's over here. We have one and we have two trigonometries. I guess that's it. Now we try to rearrange all these things. So let's zoom in a bit so that everything is clear. Of course we need one top variable also because time function is there. Keep a clock over here. So first we'll create those sine functions. This is sine, okay. This will be, we can name it as cos. Okay, done. So this goes over here. Okay, and this goes over here. Then those sine gets multiplied by twice. Okay, before that, what I've done is I've actually a bit modified my problem. Now instead of this, I'll be using this thing because this will be the input to the first integrator. It will give me this output. So this output gets multiplied by 1 by 3. So I've just just divided the entire equation by 3. Okay, coming back to the problem. So this gets joined over here. Let's copy this and we get another one. We paste it over here. Let's name it as 2 by 3. Okay, done. So going over here. Okay, so this is the summation. This goes over here, and so we get another summation which will be somewhere here. This is the input that was sine cos, the right hand side of the equation. This goes into this. Okay, now my first part is this. So this is my d square x by dt square. So this goes out, this goes over here. So this is my dx by dt. Okay, then this will go into my scope. Okay, now I need another plane. Let me rotate this in the clockwise direction. Okay, so this is my dx, which will be multiplied by 1 by 3. It goes into this. We add one more sign because there were 3 terms, so which will be, the third one will be the minus 1. Resize this. Okay, so now again we get copy this, copy that. So double click, 2, done. So this goes over here and this goes over here. Okay, done. So now we have set with this thing, and we can write over here that this is by the output. Let's just check it and we'll give the initial conditions. Over here it's the initial condition was -2. Okay, and over here it was 2. Let me recheck the things. One and 2 and 1. 1 and 2. Okay, sorry. This was simple 2 and this was 1. Okay, said and done, let's name this again some model. You can name it as ODE2, ordinary differential equation order 2. Okay, it cannot be saved because okay, no problem, we'll name it by some other model. ODE_2. It's done. So let's actually change the same because we'll keep the same time interval 5. We'll modify the input time interval. Let's start from -5. Okay, so that's it. Save it, try to run. Let's run and let's see the results. So it's again something which we got by the code, so we can compare that. You just see, I'll just show you. One is this, the other figure was this thing, so we can clearly see, we can clearly compare both the things. So whether you solve by MATLAB code or you solve by using Simulink, the results comes out to be the same. Okay, so that's it from my side. So thanks for watching. For any suggestions and query, you can mail it to me at this site.